Welcome to another RDWorks Learning Lab. If you want to switch off now, do so. But this is free gratis day. We are legally going to get a piece of software, which, okay, it's a few years old now, but it still does exactly the same as the new software, minus a few little trimmings and bits and pieces. Okay, so it's an old style of presentation, but it does exactly what we want to do for preparing photographs. Now, I know you guys, some of you are used to working or becoming familiar now with working in Lightburn, but there still needs to be some preparation of photographs sometimes before you try and burn them. There are very serious limitations within RDWorks, and so consequently this Photoshop, which you can, there is another more up-to-date version of it called GIMP, which is free. But this is the universal standard upon which most copies were based. So what I'm going to be able to do today is to show you how I'm going to get a free copy and how we're going to install it on this machine. We've gone to, literally, as you can see at the top left there, we've gone to www.adobe.com, and it comes up with this screen that says, hey, you're not an American citizen. Where are you from? So we've got to tell it where we're from in the world. And it transfers me to the United Kingdom site, which is the same sort of site. Your opinion matters. No, it doesn't. Now, before we go any further, if you have an Adobe account, then you need to sign in. If you don't have an Adobe account, you will be asked a few simple questions like your name, first name, and your second name, your email address, and I think that's probably about as much information as they really want. It isn't very intrusive, but you need to sign in to this website. Okay, now I've just signed in. Where we need to go now is to support, download and install, where we should find all this free trial stuff. Now when you get to this page, you'll see across the top here, product updates, other downloads. So we click that. If we click on CS2, it tells you Adobe has disabled the activation server for CS2. Acrobat 7, because of technical issues. These products were released more than 7 years ago and do not run on modern operating systems. Adobe no longer supports them. Well, I'm going to try and run this on a Windows 10 machine. So we'll soon find out whether it's that old. Now you have to say, I accept, because you understand that if it doesn't work, it's your problem, not theirs. So this is the serial number that you require when you start running the suite after you've loaded these. Now there are some install instructions here, which it's worth downloading and copying. It's just a PDF file. And so what I'm going to do is, first of all, I'm going to download the 3 disks for the system. Now this serial number is exactly the same serial number as the one I used for my other machine, but I can't guarantee it's going to be the same serial number for you, because they may well change the serial number with your registration. But the whole point about this is this serial number allows you to get into the software, and it's then free and it's fully functional. Okay, so I've downloaded the 3 disks now, and I'll come back and speak about those in a minute. But just for those that are interested, look, there's also Adobe Acrobat here, the Pro version. Okay, so it's old, but it will still allow you to create and edit PDF files. Now, if we look down a little bit lower in this list, you'll find that if you really wanted to, you could pick up Illustrator on its own without bringing in the whole of the suite of programs. In a similar way, you could also just go here and very simply download Photoshop. But I've taken the option to load the whole suite. Now here are my 3 files that I've got into my download, and I'm going to double click on the first one. And then it's going to save those files into there. Next, we're happy with that. So it's saving that as a virtual disk at this moment in time. Okay, next. I'm happy with that. And here's where I punch in my serial number. Now, whether I can copy that serial number? I don't know. Let's try Control V. No. So I'm going to have to put it in longhand. Next, it wants to put the stuff into there. See, it's now reading the contents of disk 3 onto the computer. It's happy. Okay, let's see what we've got, shall we? So if I go down to here and take a look at all my programs, I need Photoshop. So let's check that out, see if that's installed, which it has. And then we don't bother to register, do not register. And then we say automatically check for updates every month. No. So we won't do anything. Okay, let's get rid of that. It still did it anyway. Okay. Right, so we'll shut this down and we'll see if we start it up again, what happens. A copy onto the desktop to create a shortcut. So there's my Photoshop up there. Click, click. And this time we come in cleanly without a nag. Now, as I said, I'm using this screen at very high resolution, so it's hardly readable to probably most of you guys. It's hardly readable to me. So perhaps I ought to do this on a lower resolution screen so that you can see what's going on. Okay, so here we are in our free version and completely legal version of Photoshop. I am no Photoshop expert. I've dabbled with it for many years just to fix a few problems here and there. But as I've done the engineering on the laser machine and worked with the dots, there isn't a lot of point in me being capable of producing a good photograph but not understanding what actually makes a good photograph and how we prepare it for our laser machine. Now, although I'm going to do this for our little Chinese machines that use RDWorks, I'm pretty sure the same system will work for the expensive machines, because once we get to a dithered file, any machine can deal with it. Now here we've got what looks like a very high resolution picture. It's taken with my phone, as most people do these days. So let's go and have a look at the properties of this particular picture. And this is a key part of you understanding how your pictures work. We go up here to image and we look at image size. And you'll get this little window here. Now the first thing I want you to do is make sure you untick this box at the bottom here. So there's nothing in those boxes there. And the first surprise that you'll find is, hey, this is only 72 pixels per inch. That's a rubbish resolution. And then we look above it at the size of the picture. And we realise that it's 1.4 meters tall and 700 millimeters wide. And then if we look above that towards the top of the screen, we shall see that we've got a huge number of pixels across and up and down the screen. And that is the clue that we've actually got a high resolution picture here. If you get something which is only 150 by 200 pixels or something like that, you are going to be wasting your time. You need high numbers here, because what we're going to do here is to flip this number to the best resolution that we think we can ever achieve, which is 254. We might get to 300. But as soon as I change this to 254 pixels per inch, look what happens. The height is no longer 1.4 meters, it's now 0.4. So it's come down almost to a quarter. But we've not seen any change in the quality of the picture. If I use Control Plus, I can zoom in on this picture. And you can just about begin to see some pixels there. Control Minus will send me out to the right size, which is there. We'll just go back to our window here and we'll set this picture back to where it was, because that's what I'm going to be working with. I hear you say you can't work with a 72 DPI picture. You've just told us it's rubbish. Yes, that is correct, but that's the raw picture. which I've shown you has got the capability, there's enough information in that picture to compress the picture down and still not lose any of its quality, because it is such a large picture. If you start off with a small picture, you can't make it bigger and higher quality. You make it bigger and turn it into mush. There's our picture. Now we're going to start on the process of dealing with something that goes into our laser machine. Now I'm going to go to File, New, and we get this screen up, which allows us to specify the width. Now at the moment, if you're a graphic artist, you probably like to work in pixels. I'm an engineer and I like to work in the real world, which is millimeters or centimeters or something else. So I don't need a picture which is 677 millimeters wide. I'm going to, let's just say, finish up with a coaster. That's what we're going to put this picture onto. And a coaster which is, choose a size, 5 inches by 5 inches, which is roughly 125 millimeters by 125 millimeters. And here is where we set the resolution that we want our picture to output at, 254. If we take a quick look at these advanced features at the bottom here, we shall find that we've got a square pixel, which is what we need. We don't need to do any more other than say OK. And there's our 5 by 5 inch coaster. It looks as though this picture beside it is going to sit in the middle of that, doesn't it? Well, remember, this is a huge picture. Make sure that we've got the arrow selected at the top here, our move tool as they call it. This is the general pointer. And somewhere in the picture we'll click and hold the mouse down and we'll drag that picture across to here. Now that's a surprise, isn't it? It didn't come in at the same size. This picture has now come across at the correct resolution. And we can check that by just taking a quick look in our image file. And sure enough, 254. And it's only 125 millimeters by 125 millimeters, which is exactly what we specified. So we've got what we asked for in this picture. The only problem is it's not very well positioned, is it? Let's just have a look at that, because if I click in this picture, I can move it around, because I've got so much of the picture hanging outside the frame. Now that's quite a nice picture, but let's just assume that we'd like to see some of the buds that sit below this flower. How do I make that picture smaller? Just above this picture you'll see that there's something called Show Transition Controls. Click on that. The other thing that we need to do is, because we've got this picture, the one that's live, if you see, this one is not as dark, so this is the one that's live, and you can see that over here on the right hand side where the layers are. So what we're going to do is we're going to go into the little triangle up the top right hand corner of that layer block and click on it, and we shall find that we get something in there called Smart Object. Group into a new smart object. Click that as well, and that makes this picture now something called a smart object. We won't get too concerned about it at the moment, but it's good to have this as a smart object. Okay, next thing that we have to do is to shrink this picture down. We're not going to shrink it down and leave it there. We're going to shrink it down so that we can work on it. So we press the control key with the minus. Every time we click the minus, look what happens. Now we've found our original picture. Look, it's sitting here, and we're just taking a little window on that original picture. Okay, so we need to click on a corner handle with those little arrows, as you see, and then we need to hold the shift key down, and the shift key will constrain the proportions. So there we go, we're constraining the proportions, and we've got to be careful because we can't make the picture any narrower than our image. So there we are. Now we can now let go of the shift key. We can click anywhere in this rectangle or in the picture itself, and we can move the picture back into view. So yes, we can get those little buds in, but now we're missing a bit of the side of the picture. Back to the arrows on the corner again, hold down the shift key, and we can gently tease the picture out until it fills the area that we want. And then we can let go of the shift key, and we can now move the picture by clicking anywhere in that rectangle. And there we go. So now we've moved our picture into a nice position, and we've sized it to fit the envelope that we're going to try and reproduce. At this point, we're happy. So we can basically say OK by pressing the Enter key. We can zoom in on that picture now with our Control+ key. And look, it's still a high quality picture. We haven't compromised the picture at all. Just because we appeared to make it small, we've still got the original details in that image. So let's take it out again to any size, and that could be our final image. Now, before I save this, and you'll say, well, you're surely not going to save that because it doesn't fill the frame. Don't let that worry you. Look, I can assure you that that picture is 254 dots per inch because it's in this frame which has got properties of 254 dots per inch. This one hasn't. This one's 72 dots per inch. But as I've just demonstrated to you, we can zoom right in on this and it's no different than this one. Okay, so there's our finished picture. Now we need to rework this slightly, because first of all we need to go to Mode, Grayscale. And it says all sorts of questions there. Yes, we want to rasterize, and yes, we want to merge the layers. And there we go. We've got rid of the colour. But it looks a little bit on the dark side. The background is... the background is a bit darker than I really want it to be. So I'm going to look at this again. Image, adjustments, levels. Now I could either go for brightness and contrast or this more flexible thing called levels. So if I go into levels, look, I've got all this control here, which allows me to play with various parts of the picture. Now there is another feature which allows me to do it in a slightly different way. And that's in Image, Adjustments, Curves. So here's white and here's black. And look, if I put a dot in the middle and then I drag that dot around, look what happens. Okay, now I'm making the background lighter there. Now I've made it too light now because I've lost the detail on the petals. So there we go, we've got the detail in the petals coming out now. So if I put another click up here and drag it a little bit further, look, I'm messing around with the background. So I'm messing around with the background without actually changing the colour of the object very much. So now look, I've got this leaves and the flower to almost pop out of the background. It's no longer quite as black in the background. So this is a very powerful thing that you can play with. You can mess around with the foreground. I think the foreground should be somewhere about there. Okay. So we're happy with our picture now. What we've got to do is turn this now into a dithered image. So we can go back to Image, Mode, and this time we can do Bitmap. Flatten the layers? Well, yes, we can do. Now look, you'll see that we've already still got our 254 pixels in this picture, and it wants to output at 254 pixels per inch, which is correct. Now we could choose all sorts of dithering patterns here, but the sensible one is the diffusion dither pattern. That's the most sensible to use. Okay. That looks terrible, doesn't it? Yeah, that's just a screen presentation. So don't get too upset with what you see. What we should do at this point is to save this file, save as, and we will save it as a bitmap. Flower bitmap. There we go. Save. And we'll come back into RDWorks where we will say, right, we will import that file now. Open. I think you'll see that it's actually not that bad. I mean, it is definitely, when you zoom in, it's definitely made up of pixels. Single dots. I think that that might come out quite nicely. We need to set our parameters. We know that we can run generally at about 200 millimeters a second. Output, yes. Blowing, no. Scanning, yes. Well, we only need to go probably at around about 11 or 12 or something like that on my 60-watt tube. And the interval, well, we've set this to 254, which is 0.1. X swing, fine. No ticks up here. But there is one other thing that you must remember. Config, system setting. And here, you should have generated a table. If we're going to run at 400 millimeters a second, I needed to have done a little scanning offset test to set this number here. If you haven't done that, you could finish up with a little bit of a messy picture, even though you've got a super duper fine crisp dot potential with your lens. I have covered this in previous sessions, but if all else fails, a quick and simple check is to do this. Draw a very simple little program that looks like this. There it is. Set it to scan as opposed to cut. Doesn't matter about the power, but maybe 25 or something like that. 25. The important thing is no ticks here. We'll have X swing and set the interval to 0.5 of a millimeter. Now it might seem silly, so set it to 0.5. OK. And here we are. We're going to draw this little letter I, or the number 1, with a series of lines across it so they look like a ladder. Now, unless the ends of the ladders line up left and right, you're in trouble. And that's what this allows you to do. So if you take a look at that picture and then go to config, system setting, 400, make it 400. If you choose 399, this will not work. So you run at 400 millimeters a second. What will happen is this compensation will come into play. So you need to find out what this reverse interval is. So you just play with this number and you go back and you retest this very simple little picture. And what you do, you look at the first line at the bottom and the second line and the third line, and you make sure you understand which way they are relative to each other. Because as you make plus or minus adjustments to the offset, you'll see the lines start to change relative to each other. You will only have succeeded when you've got a nice perfect ladder where all the edges line up. I'll delete that because it's such a simple program to create. Now, I did say that we weren't going to go to the machine today. Perhaps we will, just because I'm curious about how well this will come out. It is quite a dark picture, so yeah, there's a potential for me to fall flat on my face with this one. Okay, well, I'm going to be using my little piece of beer mat card at the moment because that's the standard that I use for checking things, but we will go on and try it on a piece of wood in a minute. I've already set the focus up to about 11mm, and I've got this rather nice clean dot pattern here which I've established, so I know that the focus is correct. I'll set the increment up to 0.1 and we'll give it a try. 254 dots per inch. Just turn the fan on and we'll close the lid for a minute just to let the smoke draw away. Well, let's have a look, see how we're going. Just turn all the noise off. Including the little vacuum table. That's not a bad rendition of my pretty risky dark picture. And I have to say that here, where you would think at this boundary line there would be a big step where it's burnt, it's absolutely flat. There is no 3D-ness in that picture at all. It's not sticky. So the dotting was absolutely perfect. And we'll just compare it with the original. And you can see all the detail has come out. Now we'll try the same thing on wood, because wood has got completely different properties to this beer mat card. Now, as I mentioned to you before, when I do this thin 3mm plywood, I put magnets on my table like this. So I've got 9 magnets on here, and I'm going to drop the board on here. And this particular board is actually not too bad. Some of them are quite badly warped, but this little trick here with a magnet on top and a magnet underneath fixes the problem. It's okay in the middle there, it doesn't push down, so it's, if anything, it's supported by the magnet underneath. If it was lifted up, I would put a magnet in the middle there as well, but I don't need it. Now, as I've mentioned to you before, you cannot guarantee absolutely that the focus is going to be the same for every wood, every material, every speed and feed that you use. So I think the nominal speed that I used on here before was round about the same at 150mm, but I think I put the power up to about 20 or 22. So I'm going to do my little dot test at the same parameters. The setting on here is nominally 11mm. So here we are down at about 10.8 now. Oh, that sounds really nice and crisp. In the corner of my table here, I've made myself a little thumb wheel so that I can manually adjust the lead screws to give me reasonably tight control on my focus, because my little buttons go in steps which are too coarse. Well, the detail on this wood is not too bad. But the problem is, because the wood has got a creamy colour to start with, and it doesn't burn with such a black colour, it doesn't have the tonal range of the paper of the card. There is just a hint there, in places, of 3D-ness, but it is nothing more than a hint. So as I get up here, I very carefully eased the focal distance at a point here. You might be able to see a line across there, and I can feel that it is slightly rougher here than it is here. In other words, the focus was just very slightly out. So as I change the focus, and in fact I decrease the focus, you'll see there's a slight change in the colour. And there's also a slight change in the texture of the wood, the finish. So I've got it more or less correct now, whereas I didn't have it quite right to start with. So again, we've got some quite nice detail in the flowers themselves. Well, here we have a comparison between the card and the wood, and as you can see, the wood has got a far lower dynamic range as far as colour is concerned. It's brown to cream as opposed to almost white to a very, very dark brown. Now, this bit here was where I started off with too much power. I started off with 20% power, and I had to back the power off to about 15%, I think, because I could see here that my browns were not the background colour, which is what I was expecting. So I was getting over burning here, and you can feel it in the texture, and in fact there's a small ridge across the bottom there. So my dots were definitely overlapping and over burning there. So by decreasing the power, I decreased the size of the dot effectively. Having seen these examples, and as I said, this is not necessarily the best example that I chose today, but it demonstrates the principles involved with trying to process a picture through Photoshop without losing its resolution. So you can set the resolution in Photoshop to the final resolution that you want to work with and just pass it through RDWorks or whatever your software is to run your machine. So you don't need a special piece of photo preparation software. This is dotting software. You can in Photoshop do net graphics as well, but yeah, I would steer away from net graphics. You could also try, remember, one of the steps that we pass through as we prepare this picture is grayscale. Once you've got your grayscale picture on the screen and you've done the necessary brightness and contrast adjustment, there is no reason why you shouldn't then also convert it back into a grayscale image before you save it. The temptation was too great once I mentioned it, so I've loaded my bitmap back into Photoshop, and we're going to go up here to Image, Mode, and we're going to turn this back into a grayscale image for a few moments. I know it can't be grayscale because it's black and white, but what we will do now that we've turned it back into a grayscale image, we will do a quick check again with adjustments, levels, and we'll find that we've got output levels here of 0 to 255. Well, all I've got to do is to change that to 250, 250, and it's no longer white, it's almost white. I can then do OK and save it. So now that I've saved it as a grayscale image, it's a grayscale dithered image. I can now go back into RDWorks. To all intents and purposes, that's exactly the same image. There's just a fraction less white in it. But what we have got the opportunity to do now is this. We can bring up our bitmap parameters, and we can now select this output direct, which means we're going to go into grayscale engraving. In fact, we'll push the speed up to about 400, I think. And then we will leave the minimum power at 1, and the maximum power, it's difficult to say what that should be. We'll have to experiment with that. But it could well be that it's 15 might be good enough. We'll leave it on X swing, and we'll leave the interval set to 0.1. Well, that's certainly a pretty muddy result that we've got to start with there, so I've stopped it. And what I think I'll do is to change the speed dramatically by 50%. We'll come back down to 200 millimeters a second. Yeah, we've got lots of burning now. It's not that bad. It's got a little bit of a 3D feel to it, but hang on. That's what we were trying to do. We were trying to do some 3D engraving, but with very, very, very low values. I mean, it's very, very slightly muddier than that one. This one is a little bit crisper than this one, but on balance, it's again about a 90% comparison with dotting. And I'm absolutely quite staggered by this. So this is still worth investigating further in another session. So good luck with your downloading of Photoshop, and lots of happy hours of playing. Until the next session, goodbye.